The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody, and welcome to the Gala webinar series. My name is Manuela Noske, and I'm the Communications Manager at Gala. Gala is a global nonprofit trade association that enables communication and business across languages and cultures. We're headquartered in Seattle, Washington, in the United States. And today we have a presentation by Marcis Pinnis and Arturs Vasilevskis from Tilde, who will talk to us about a world without English. But before we get to our topic, I need to go over our housekeeping items. First of all, as always, everyone's lines are muted to cut down on any noise. If you have any technical problems, let me know by using your chat box, and I will try to troubleshoot them with you. If you have a slow internet connection, your audio may be disrupted. If that happens, use the number listed on the GoToWebinar panel to call in using your phone. We are making a recording of this presentation, and you will be able to find it following the presentation on Gala's global website. All participants will receive a link. If you have any questions or comments, please type them into your chat box, and we will try to get to as many of your questions as we can with the time after the presentation. Next, let me introduce our speakers. Arturs Vasilevskis is the head of machine translation at Tilde, where he leads the machine translation group overseeing all aspects of MT product development and sales. Arturs believes in the importance of multilingualism and information accessibility. His team has developed Tilde MT solutions that cater to all user groups, starting from the individual users to translators, businesses, and large-scale international organizations. His team has been recognized internationally for its achievements 3 years in a row in the WMT International Machine Translation Competition, where it competed against the world's major technology companies, research centers, and academic institutions. Marcis Pinnis is the Chief AI Officer at Tilde. He has an MPhil degree from the University of Cambridge and a PhD degree in computer science from the University of Latvia. He has published over 50 scientific papers on machine translation and other topics relating to natural language processing. Marcis is an AI-powered technology expert, and his current research focus is on neural machine translation, including hybrid methods for neural machine translation, terminology integration into neural machine translation systems, and domain adaptations of strategies of neural machine translation systems. That's it for my introduction, and it's now time to turn the floor over to Arturs and Marcis.
All right, thank you, Manuela. And also a very warm welcome from our side. It is our honor and actually privilege to have you all here in this webinar. And I really hope that everyone is feeling healthy and safe in these challenging times. Today we will have a joint webinar virtually. Next to me is Marcis Pinnis, and my name is Arturs Vasilevskis, and I will be mastering the presentation. So Marcis, please let me know when I move to the next slide.
Okay.
All right. So at the first glance, it may look that nowadays it is clear and pretty simple where and how machine translation can be used. I personally believe that there is an overlooked potential and opportunity for use machine translation in business environment. And today in our webinar, we will discover through the use cases how a custom solutions, a custom machine translation engines can open a new opportunities and actually make savings. And from Marci's side, there will be a presentation on enlightening how a state-of-the-art custom machine translations are being developed and what are the main challenges in that aspect. And answering to the question, is there a world without English, or actually how big is the world without English in terms of the languages? And the facts are that half of the world is speaking in largest 23 languages, and the other half is speaking in more than 7,000 languages, and only 21% of English native speakers represent of 23 largest language group. And during the last 20 years, there have been made a huge shift in internet content availability. The dominance of information availability in English is dramatically reduced. Now more than 70% of the internet content is available in the other languages instead of the English. And there have been a recent survey made by the Eurobarometer that shows that actually 62 of Europeans can't hold a meaningful conversation in English. And we, Tilde, as a European-based company located in all 3 Baltic countries, in day-to-day communications are facing with the multilingual communication challenges. We, as a pure AI technology-driven company, we started actually from the 1991 our developments and research for our solutions in cooperation with the leading universities. And machine translation is not the only one modality in which we are working in. We have also experience and solutions in virtual assistants or so-called smart chatbots, speech technology, and natural language understanding. We really do believe that AI-powered technologies are crucial for today's multilingual world. Machine translation support translators by providing translation for simple sentences, so that translators can bring added value to translation process itself. Also, machine translation provide multilingual access to the information. For example, millions of people now who are who speaks less or less popular languages are limited in access to the trustable resources related to COVID disease. And machine translation can address this information access gap. So there are a huge potential for machine translation technology. And now I will give a floor to my colleague Marcis. He will explain how a custom direct machine translation engines are being developing and what are the main steps in this process development. Marcis, the floor is yours.
So hello again. Okay. So in these couple of minutes, I will tell you some of the challenges that we address when developing neural machine translation systems for non-English language pairs. So not necessarily English language pairs, but non-English language pairs. But before I do that, I will start by briefly describing what processes are involved in machine translation system development. So the first step that highly depends on customer involvement is data acquisition and management. If you want to have a machine translation system for your specific needs, you must have or be ready to provide data that we or any other machine translation developer can use to either train MT systems or adapt MT systems. Therefore, it is important for customers to also have data management procedures in place. Whenever we develop systems together with our customers, we obviously help our customers with these processes whenever necessary. The next step is data preparation. where we clean the data, normalize the data, and in various ways split the data down in smaller chunks so that they can be fed to the next process, which is MT system training. Nowadays, MT system training is based on deep neural network algorithms, and once the models have been trained, they are deployed for customers using whatever integration methods customers require. Those are, for instance, computer-assisted translation tool plugins, various APIs, web interfaces, mobile interfaces, and others. Now, if you require a machine translation system between two non-English language pairs, you have two options. If you do not have any data available, typically an on-the-spot approach is to use a private translation system that is already available. For instance, Google provides MT systems between many language pairs, but for most, even if you don't see it, it provides a private translation approach where your translation request is first translated into English from a source language, which could be, for instance, Swedish, and then from the English translation translated into a target language, which could be, for instance, Finnish. However, if you decide to use pivoting, then you must understand that when pivoting, you are losing on quality. That is, the pivoting process introduces errors when translating from the first language to the second, and those errors accumulate when you translate from the second language to the target language that you want to have your translations in. Consequently, this degrades MT quality. This is why a direct translation approach can be a much better choice, especially if you have data for adaptation of machine translation systems. We can move on to the next slide. Private translation faces also other challenges, like domain mismatch and sometimes even dialectal mismatches. For instance, if you would require translation between Finland, Swedish, and Finnish, or Swiss French and Swiss German, a custom-built direct translation system would be a much better fit, simply because public engines are not tailored to handle dialects nor particular domains. And we see that whenever we train custom systems between non-English languages also for our customers. Now, if custom direct translation systems are the way to go, what are the challenges that we are facing when developing such systems? The main challenges, obviously there are more, but the main ones are data availability and data sparsity. I will start with data sparsity. If we compare English to other more morphologically rich languages by looking at parallel data, that is the data that we use to train neural machine translation systems, we see that the English side typically consists of a much smaller vocabulary. And here in the slide, you see an example where I have two language pairs together with English, Latvian English and Estonian English, and both the Latvian and Estonian vocabularies are much larger than the English one, although it's parallel data, so it is supposed to have the same on both sides. So English has much less sparsity. And this in turn means that data sparsity for morphologically rich languages can be much greater, and current neural machine translation algorithms do not like data sparsity. If we pair such two languages together, we are faced with two issues. So first, lack of data, because whenever we pair something with a language that is not English, we are facing with lack of data issues, and even greater combined data sparsity, because both of the languages are morphologically rich. We can move on to the next slide. So what is even more typical parallel data for morphologically rich languages can feature just a small fraction of all the words that are available in a language. For instance, Latvian contains more than 20 million words, but parallel data that we have available for training of machine translation systems features up to 1.3 million words. So this poses an obvious question: how do we make sure that the system can also handle at least some of the missing 18.7 million words? We can move on. So the answer is that we either acquire more data, but as I said, it's a difficult task, or we apply methods that allow reducing data sparsity. Or better, we actually try to tackling both of these solutions. Let's move on. So the methods that we apply for handling of data sparsity are twofold. First, methods that reduce sparsity in general and could be also applied for English, and methods that are meant to help specifically morphologically rich languages. The first ones involve filtering noise out of data, cleaning segments, normalizing punctuation, identifying and handling regular and non-translatable entities, for instance, emails, various codes, customer-specific placeholders, etc. And the second ones allow injecting linguistic knowledge into the data. And here, the most useful method for sparsity reduction and quality improvement for us has been morphologically driven word splitting. I'll briefly explain what that is. Typically, when we train NMT systems, data is pre-processed such that words are split into subword units. So no neural machine translation system translates words as words. They translate words split into smaller chunks, and this allows the NMT system to translate words that it has never seen, and hence have support for an open vocabulary. So this allows us to bring some of the missing words back, so we can translate something that has not been seen in the training data. However, standard methods for word splitting do not handle morphologically rich languages well. We typically apply word splitting that is morphologically guided, such that we make sure that different inflections of the same word are handled consistently. And this is the difference between standard statistical methods, which do not care about language, and morphologically or linguistically motivated methods. And this, in turn, allows us to improve quality also for rarely observed inflections of words, and improve machine translation quality in general. We can move on. Now, if we talk about data, it is important to understand that for MT system development, we do not only use parallel data to train and adapt machine translation systems, but also monolingual and bilingual terminology, which is sometimes not considered by customers. So it is therefore important to manage and have procedures in place not only for parallel data, that is translation memories, but also monolingual and terminological data that is specific to your industry, specific to your domains. So if you have textual data that describes your industry, describes your domain, it can be used to actually improve machine translation quality for your specific needs. We can move on. So customers do not always know where to look for or what constitutes data for machine translation system development. So if you are from a translation agency, translation memories are typically the data we are looking for. But if you are from a company that does not translate much or does not have specific translation use cases for your specific requirements or where you actually need the machine translation system right now, Then monolingual data that is available on your website or in your work documents or emails or customer communications can be a valuable resource for MT system development. On top of that, whenever we train machine translation systems, we try to use also public sector data, books, news, and public translation memories whenever possible and necessary. And let's move on. So to conclude what I just told you, if you require a non-English machine translation system and you have data, then custom direct machine translation is the way to go. It is important to use methods that reduce data sparsity when developing MT systems, and that is crucial to actually boost machine translation quality, especially for non-English language pairs. If you want to get a quality system, then you have to be able to provide your data for MT system development, or you actually need to provide the MT system developer sources where to look for your data. And machine translation benefits not only from parallel data, but also from monolingual data when parallel data is scarce. So that's it from me for now, and I'll return the presentation back to Arturs.
All right, thank you, Martis. And in the following part, I will share a use case where such custom machine translation solutions are used in different industries. And I will start with the, I assume, well-known industry, which is localization. And the use case is from the Switzerland. And as we know, in Switzerland, there are 4 official languages, which are Swiss German, Swiss Italian, Swiss French, and Romansh. And all official documentation need to be delivered, translated in all 4 official languages. And there are high security requirements for the data exchange, so not all services outside of the Switzerland can be applied in translation process. And additional challenge is that there are a high organization cost pressure. So there are definitely opportunity for the automatization. And the solution which address those challenges and was introduced in the company daily workflow are a custom direct machine translation engines between all official languages. And in order to deliver best possible translation quality, engines are actually divided or customized in a specific subdomains. So for example, legal, finance, legal court decision, criminal law, and so on. And the way how actually we manage to create such subdomain engines was by joint effort on a data preparation and segmentation those data in those several domains, and of course tunes in neural networks. To address and assure high quality requirements, the whole solution was deployed on a local Switzerland-based infrastructure, so that all data, all translations are kept in the Switzerland territory. And actually more interesting was that in addition as additional service with which the company come up that greatly differentiates from other localization company is an online secure platform where existing customers can by themselves translate text, full text office documents in case where urgently there is a need to understand the content of the document, of course in a secure way. A slightly different use case which I would like to share with you is from e-commerce sector, And as it comes, when a local e-commerce shop plans to expand and provide products to the new markets with the foreign language, the challenge which are faced, how to translate thousands of product descriptions without within the very specific domain, with high repetitiveness and unfortunately within the limited budget. And the applied solution was by introducing a high quality domain machine translation engine, and also by dividing the product description in two categories. The first one, the most popular and important product descriptions, where high quality MT can be applied, and afterwards these translations are forwarded for professional translators for a review. And the other category where pure machine translation is good enough for understanding the description, but with the clear notification that translation is made by the machine translation. By such approach, a company can significantly reduce time required for entering new local market. And the most important is that by such approach, significantly can reduce costs for less important information translation. And the other experience and the use case from the EU Council Presidency Translator, machine translation service, which we provide for the hosting country of the Presidency of the Council of the European Union, and particularly to the Finnish government. Challenges facing during the presidency hosting were that there are a need for a large amount of translation, which should be made under the time pressure in all official languages. And as we know, in Finland, there are two official languages. One is Finnish and Swedish. And in addition, to ensure the presidency requirement, the whole content also should be delivered in English. And the solution was to introduce the custom machine translation with the adapted language style and terminology used during the presidency. And machine translation was integrated fully during the translation process, so that actually translators need just to review the text, spending more time on a sentence meaning improving where it was required. And last but not least use case is from the Latvian public administration. In Latvia, there are a significant amount of minorities which are speaking in non-official Latvian language, for example, like Russian, German, or English. And the challenge is how to deliver and make actually available a waste of e-services provided by the government, which are available for the citizens. And those e-services are such as tax reporting platform, enterprise register, sick leave submission system, and so on. And those services are rapidly developing, and the content is dynamically changing. So actually, it makes almost impossible for human translation to provide this content in several languages. And as an additional challenge is how to make available and accessible the content of official and trustable web sources for all of citizens. And the way how Latvian government address those challenges was by introducing a national language translation portal where all citizens have access to high quality secure environment for a translation, where every citizen, free of charge, can perform translation for several purposes, for example, for education, for translation, for web content translation. And actually, it's the same machine translation service provides translation for all e-services which are provided by the government, and also in the same way can be used for government website content translation. And to sum up, through those use cases, we can see how we can businesses or other services greatly benefit from a custom machine translation solutions by more efficient way how to perform translation, reserving highly valued translators' time for bringing added value in a translation process. Also, how a company can address new markets in more cost and time efficient way. And finally, how a custom machine translation can open new services and differentiates, it was in our one of the use case, the localization company from other similar companies. So, for the remaining time, we will be happy to provide answers to your questions. Thank you so much for the listening.
Thank you, Arturs, and thank you, Marcis. We have, let's start off with a particular question here that that arose when you were talking about your first use case, the Swiss Army, not Swiss Army, the Swiss company. And that question is, do you get any additional training data by back translating monolingual customer data?
Well,
okay. Actually, Martis, maybe you can take on this question, and I will elaborate it more.
Yeah. Okay. So, yes. So typically, it depends on what data every customer has available. As I explained in my part of the presentation, monolingual data is as important for adaptation of machine translation systems as is parallel data. So if parallel data is scarce or it cannot be obtained, or the quantity of it is not sufficiently large, we require monolingual data. And it's not like we require, it's actually a very good method of how to boost quality in certain domains.
Thank you. Artis, did you want to elaborate, or shall we go on to the next question?
I think we could move on.
Okay, cool. So the second question is about the public MT portal use case that you cited. How is user feedback collected and managed for such a large number of users?
Probably this question I will take, Martis, if you would like to elaborate. So just let me know. But this option to provide the feedback is very important, and there is several ways how actually we are getting this feedback. There is an option when user receive a translation, there is an option to provide the feedback or provide better translation. So this all feedbacks are collected and during the time analyzed, and improvements for the engine or platform itself are made during the time.
Mm-hmm. Thank you. Thank you. And the next question is around terminology, and it's specifically targeting Marcis, and that is, could you talk a bit more about integrating terminology into MT? So for example, is there any specific requirement that the terminology has to meet? What works best in your experience?
So the methods that we are working on, there are two types of methods. One type of methods where we guide the neural machine translation decoder. So the neural machine translation system, when it outputs the translation, we use terminology to limit what the machine translation system can translate. There, typically, we require that the terminology that we use can be also provided in a morphologically rich form. However, that's not always possible. So a different method, which we believe will be much more superior, is where we identify terminology before translation. Then we train a neural machine translation model that becomes aware that the source text can have annotations. So the neural machine translation model is trained to expect that it can receive in input data already annotated data with terminology marked. And in this particular use case, all that we need actually is the canonical forms, so the base forms or the dictionary forms of terms that we find in dictionaries. And this is much more powerful. And there's a specific way of how we train the neural machine translation models so that they become aware and they learn to actually use the translations that we provide them in the annotations, and they learn themselves to perform inflections. So if you require translation into a morphologically rich language and you want to constrain the translations using a term collection, then you do not need to have a term collection that lists all the different inflections, the dictionary forms.
Thank you.
So if I should elaborate more, then you can ask a follow-up question, and I'll try to elaborate further.
All right, I'm sure she will. Thank you, Marcis. Here's a question about word splitting. Can you provide an example of how word splitting can solve the scarcity issue?
So imagine that, so that's also a question for me, I guess. Imagine that you need to have a machine translation system that translates into, let's say, Latvian, Russian, Lithuanian, whatever. So a morphologically rich language, which for each word where each word can have multiple inflections. So for instance, in Latvian, an adjective can have over 100 different inflections. In Russian, the situation is even more severe or more challenging, to put it in this way. So the standard methods that split words into subword units, they analyze statistics. They analyze statistics over the whole data set. And by doing so, they do not follow any linguistic motivation. So, and how that results is that half or part of the inflections are split in a way where you find a split in for instance, the root of the word in 1/2 or 1/3 or 1/4, whatever cases you would find splits, different types of splits. For instance, you would have the root completely preserved, and this type of inconsistency, where you, for different inflections of the words, you find using the standard methods inconsistent splits. So the root is messed up. The endings are mishandled. Sometimes they are joined with a part of the root. It addresses, or it actually does not solve the data sparsity issue in general. It works towards solving it, but it does not solve it. So what we do need to do is to guide that splitting process using a morphologically motivated method, where we make sure that if there are 100 different inflections of a word, we make sure that the root is always split in off consistently and in the same way from the endings and not by messing it up. And this allows us to actually translate rare forms of those inflected forms, which otherwise, if we would use the standard methods, would not be possible. For instance, the system would learn to translate the most frequent splits, but not the infrequent splits of a particular word. And that actually lowers the translation quality. So that is why linguistic information that we can provide to the algorithm is valuable and helps.
All right, thank you. Thank you for elaborating on that. We got another question here that similarly may need elaboration, and that is at the beginning of your presentation, you talked about collecting data and training MT engines. You mentioned that you can even use monolingual data to train your engine. How can you do that? Could you please describe that? What does that take?
Yeah, so typically the type of monolingual data that we use is target-side monolingual data. So if you have or need a system for a specific domain, so in a specific industry, so specific text types, then and you have target-side monolingual data, for instance, technical manuals that you want to translate technical manuals, or you want to translate emails and you have been writing in that target language, or you can accumulate that data language. The way how we use it is we train a reverse machine translation system first. We back translate all the target side data into the source side, and then use that as a synthetic corpus. So it's like a data augmentation method, which allows us to enrich or supplement the parallel data that we have with domain-specific and specifically target-side domain-specific data and adapt the system. So we use the synthetic corpus together with the parallel corpus to train the neural machine translation system that you want to have.
Right.
And this is a very effective method in cases where parallel data is not available in a particular domain.
All right, thank you so much. Our questioner here saying great answer. Thank you. Perfect. One other question here that has come up: do you ever use crowdsourcing to feed the MT engines? Assume there is a scarcity case. Do you ever crowdsource just so that you can then train?
I can answer it. Well, we haven't done any crowdsourcing.
Okay,
yeah, that's all I.
That's the simple answer. Thank you. So you briefly talked about, MT system development. How much data do you really need for a custom MT system? And how long is the MT system training phase?
That's again a question for me, I guess. Regarding the data amounts, usually the rule is the more the better. But MT system domain adaptation usually starts when we have starting from let's say 50 to 100,000 parallel sentences, or if we have monolingual data, it's usually from 200,000 upwards. then it makes sense to perform domain adaptation. However, there are also methods like online learning, which if you require a machine translation system that helps translators, then online learning can be applied also or already if you have, let's say, 10 parallel sentences. That online learning can already start showing positive results. So there's the minimum is much lower. The second part was about training time.
How much data?
Yeah,
so how long does it take?
Yeah, on top of the domain-specific data, we would typically use all the parallel data or tailored to a specific domain parallel data that we have available ourselves in our data library. And typically, when we train systems, the corpora amount from 4 to 10, 20, 30 million sentences. It depends. But that's a data amount that we typically use and have available for training various systems. And the amount varies between language pair. So, for instance, if you would need a machine translation system between less resource language pairs, let's say Maltese, Hungarian, then we would probably have to start with the lower ends. And if you would need to have a machine translation system between German and French, we would probably be able to start with 40 or 50 million parallel sentences. Depends on the language pair itself, but the amount does not necessarily tell you what the quality will be. Usually, it depends highly on the domain itself and whether it's narrow or wider, and how much data a customer can provide to adapt the system for a specific need. Now, coming to the second part of the question regarding time, in order to develop a machine translation system, if the data is already available and we just upload the data to our platform and start the training, then it takes approximately a week to train a system. If we need to process data, then the data processing can take up to a week, and then we have a week of training a neural machine translation system. That is if we do not perform domain adaptation using back translation. If we use back translation, then the typical time is something like two weeks for getting a system ready. And then, if we need to assist a customer to actually collect data, to, for instance, scroll the customer's website or help in data management procedures, then it highly depends on actually the customer's involvement, and there the time can also be longer, depending on what we need to collect and what we need to process. So it depends. It is highly depends on the use case and the training scenario that we want to apply. It does not. Time does not depend so much on the amount of data that we need for MT system development.
Mm-hmm. Thank you. Thank you for explaining. Oh, sorry. Go ahead.
Yeah, maybe a couple of words. I will elaborate Marcis' response to the question. So just to sum up, and from the user perspective, usually, so if we can imagine this machine translation system training process can be divided in two processes. One is the data acquisition or data identification. It's usually around a 1 week process, and the next one is the MT system training itself. And as Marcis said, it's also around 1 week, and then the system is ready for to go and actually ready for customer testing. And other improvements like fine-tuning terminology and other lexical improvements can be also made during this system usage.
Thank you. And I think this is going to have to be our last question, but I'm wondering if you could talk a little bit about current trends in MT development. So are there any new technologies that you guys are working on or that you're aware of and are considering?
Yeah, so I can start, and then Arturs, maybe if you want, you can continue.
Sure.
So the two large improvements or large methods that we are working on and will soon be also offering to customers are online learning for neural machine translation systems. And I briefly already mentioned that in one of the previous questions, where a translator, when translating a document, if he or she works on using a machine translation system which is static, so doesn't adapt, he or she can get very confused or angry if the machine translation system produces the same mistakes again and again. So one way to solve this issue is to feed back the translators' post-edited translations and adapt the system dynamically. So during the translation, so that for further translations, so further sentences in a document, the system would already know that or how the translator translated the previous sentences. So online learning for neural machine translation systems is one of the next steps or next big things that we also will have in our platform. Then another method or technology that we are actively working on is terminology integration, and that I also actually described previously in one of the previous questions, where if you can provide a bilingual term collection for your specific use case, so for if you require a machine translation system and you provide us data and you provide also a term collection, we can make sure that whenever we translate text, documents, computer-assisted translation tool requests, we identify terminology in the source text, annotate it, and inform the machine translation system about what the expected translation of the terminology is. And that is one thing that will also be available in due time. And then there is in machine translation research, obviously there are also other areas, for instance, document translation. So current machine translation platforms operate on sentence level, so they translate sentence by sentence, but the next big quality improvement, if we don't count online learning and terminology integration, will probably come from considering document context as well. So not translating sentences in isolation, but translating sentences in context. And then there is another totally different area, which is speech translation and simultaneous speech translation, which is a totally different area from text translation.
Thank you. Arturs, anything you want to add?
Just to highlight that the next big thing which is in our pipeline is this online learning or dynamic learning, and just to highlight that the professional translation or localization industry will I assume, greatly benefit from this functionality due to the fact that there is a very dynamic translation or post-edit exchange, by meaning that from this post-edits or made translation, this engine can dynamically adapt to the style domain on which particular translator is working.
Mm.
But nevertheless, also there is a potential for this functionality, for example, web page translation and many other actually currently unexplored the ways and potential where machine translation can be used in a business environment, because currently, taking account the situation, this business environment, digital environment is very dynamically developing.
Mm-hmm. Thank you. Thank you so much, Arturs and Marcis, for sharing both your experience but also your expertise with us today. We really appreciate it. And another big thank you to our audience for posting all of your questions and for joining us today. We would really appreciate it if you could just take a minute to give us your feedback on today's session using the post-event survey. It is short, but your input really helps us to continue to refine our webinar program. And with that, I wish Arturs and Marcis a good evening in Latvia, and I wish many of you a good day, depending on where you are. Be well, be safe, and I hope to see you at another Gala webinar soon. Bye-bye.
Thank you.
Thank you. Goodbye.
Bye-bye.